We've had a great discussion so far. We're going to keep it going. Our next session is modernizing your facility operations by leveraging digital twins with analytics. And this is presented by Ziwei Li, the Director of Innovation and Incubation Solutions at Iconics. So Z, I'll let you take it away.
Thank you. Hello, everyone. Thanks for joining me today. My name is Ziwei Li, and I'm the Director of Innovation and Incubation Solutions at Iconics. My experience is in architecting enterprise-scale solutions for customers all over the world with Iconics technologies. I'm also passionate about digital twins and evangelize it both internally at Iconics and also externally with customers, which brings me to the topic today. So this is the journey I'm going to take you on today, starting with a brief intro about Iconics and then diving into digital transformation and the role that digital twins plays in that transformation path. So let's start with a little bit about Iconics. Iconics is a group company of Mitsubishi Electric, and we have been in business for over 30 years with installations over 100 countries and 400 partners worldwide. We are a close partner of Microsoft and have been recognized 6 times as Partner of the Year. Our software is deployed in many industries, from buildings to manufacturing, energy utilities, oil and gas, and public infrastructure. We have over 375,000 applications deployed worldwide, and here are some highlighted customers. All the customers highlighted here use Iconics software to build large, multi-system enterprise solutions for monitoring of equipment, its environment, and energy. In almost all of these solutions, we also perform anomaly detection and data analysis of the collected data. So let's start talking a little bit about the digital transformation path. The journey to digital twins starts with the digital transformation. Digital transformation is a key initiative in many organizations today, with the overarching goal of digital transformation to augment and accelerate processes via digital solutions. In essence, to leverage technology to make what we do easier, better, and faster. To achieve digital transformation, there is a path to follow between what the process is today and what the ideal result should be. The first step in the path is to identify what should be improved and our goals for improvement. It could be the process of keeping occupants comfortable in the facility or the process of managing energy spend in the facility. Then we identify the assets or equipment that contribute to that process. Once we know the what of the process and assets, we need to measure how these processes and assets are doing today to form a baseline. To do that, we need to understand what telemetry is available to be measured. During the discovery process, you may find that there is insufficient telemetry available, and you would need to expand the available telemetry either through hardware refreshes or program updates. Once we have identified what we want to measure, we can put in place a system to collect the telemetry. Having collected the telemetry, it allows us to measure the process's key performance indicators, or KPIs. And understanding the KPIs is how we can identify what improvements need to be made to achieve our intended goals. As they say, Rome is not built in a day. Similarly, improvements to any process is also not a one-way path. Every improvement must be remeasured by collecting telemetries, measuring the relevant KPIs, and assess if the goals have been met by checking if the KPIs have improved. The steps of telemetry collection, KPI measurement, and improvement identification is where digital twins can help. Leveraging digital twins, these interesting use cases can easily be realized. With digital twins, it makes it easier to do continuous monitoring of your equipment and environment. Along with monitoring, it enables condition alarming to alert you about anomalous events. Since digital twins enables contextualized data history, the ability to perform historical analysis is one of the key benefits of digital twins. Leveraging the normalizing power of digital twins, it allows for effective comparisons between like equipment and environments. With digital twins, remote configuration also becomes possible. With the realization of these use cases, the effects you start to see are faster response due to the ability to remotely monitor equipment, reduced downtime due to immediate alerts of anomalous conditions, improved performance due to historical analysis, increased efficiency due to the ability to spot low-performing equipment with easy comparisons between equipment, and lower cost of ownership due to the ability to remotely configure equipment. So let's delve deeper into what makes up digital twins. A digital twin, as its name suggests, is a digital representation or a twin of a physical object or equipment. As an example, here we have an air handling unit. The digital twin of the air handling unit is represented at its most basic form by various telemetries that the equipment provides, like temperature for incoming and outgoing air, humidity of the air passing through, airflow pressure, and speed of the fans in the unit. Since the telemetries are how we understand an equipment digitally, the more telemetries we can get from an equipment, the better our understanding of the equipment. With telemetries and the collection of the telemetry data, we can define key performance indicators, or KPIs, that help us understand if the equipment is performing well or not. By measuring things like rate of change, comparing against limit thresholds and ideal targets, and recognizing patterns of behavior through the collected historical data. Across the industry, telemetry from equipment can be available in many different forms and protocols. In some cases, for the same equipment, different types of data may be available via different protocols. So it is important to ensure that the platform you choose for your digital transformation can ingest data from a variety of protocols. For example, a platform like Iconics, with its support for a variety of industrial and IT protocols, is a great example that lets users connect to data wherever they are into a single unified digital twin environment. Once data is ingested into a digital twin, that's when things start to get exciting. Most immediately, you break free from the protocol-based silos of data and reestablish the relationship between the data and its equipment origin, not to its method of data acquisition. Having reestablished an equipment-based perspective of your data, the digital twin of the equipment can be organized into a structure that represents the equipment's physical relationship to the environment it operates in, or a logical relationship with its parent, peer, child equipment, or both. This results in data being available from a possibly cryptic address with protocol-specific restrictions to something that is descriptive and easily understood. The goal, ideally, is to create a digital twin of the equipment and its operating environment through data telemetries, such that a human-centric understanding of the process is represented digitally. Now that we understand the basics and purpose of digital twins, our next challenge is to efficiently create all these twins of equipment and environments that exist around us. To address that challenge, a digital twin platform must have a method of bulk configuration based on a templated approach. With the templated approach, we define a twin template for each unique type of equipment, and then use that template to create instances of the equipment type, applying attributes to the template that make each instance unique. In Iconics, our twin template is called an equipment class, and our bulk configurator is called the bulk asset configurator, or BAC for short. An Excel workbook defines the individual instances of equipment with their respective parameter values for the template. The BAC then processes it to create the individual equipment in our digital twin environment as it works. This not only speeds up the process of creating the digital twin environment, but it's also more manageable if updates need to be made to equipment of a particular type. For example, if a new telemetry is made available or an event threshold needs to be updated, all you have to do is update the twin template and use the BAC to update all the instances. By ingesting and organizing equipment telemetries into their relevant digital twins and twin environments, we now have a system that lets us know holistically how the equipment is doing right now. While this is great, the true benefit of digital twins starts to be more apparent when we augment it with additional capabilities. The most natural thing to want after we have real-time data is to log that in history as a time series so we can look back and understand the historical performance of the equipment through its telemetry history. In the Iconics AssetWorks digital twin platform, adding historical data logging is as simple as enabling it for telemetries that we want in the twin template. Define that configuration in the template, run it through the bulk configuration process, and in a matter of minutes, we've enabled historical data logging for the desired telemetries for all the equipment of the same type. And because this capability is enabled on top of the existing digital twin environment, all the investments made to organize and describe the digital twins are leveraged for history as well. The same capability augmentation applies for alarms, but instead of at the tag level, it is at the twin level. This distinction is important because this means we can now define more interesting alarms that compare not just one telemetry to a threshold, but can involve multiple telemetries with logic to result in better alarms. For example, alarms that only get triggered if the equipment is in occupant mode combine with evaluations of outside air temperature, supply air temperature, and condition duration. By leveraging the unifying power of a digital twin system, we reduce the volume of alarms by using all the available information from the digital twin to do a first pass evaluation. This lets the operator focus on the alarms that really require action, instead of spending their time verifying if action should be taken on an alarm. Additionally, because the alarms are applied on top of the existing digital twin environment, the investments made to organize and describe the digital twin and its environment automatically apply to the alarms, providing much better context to the alarms, which in turn support better decision-making when an alarm does happen. Just like alarms, digital twins can be augmented with faults. The interesting thing about faults is that since we now have a holistic view of the equipment and its operating environment, faults can be defined to look beyond an equipment and be used to assess the whole operational environment, thereby discovering system or environment level issues that otherwise would have been hidden. Many more capabilities like these can be added on to the digital twins environment that unlocks a whole new realm of possibilities. With the backend configured, let's talk a little bit about how digital twins improve our visualization of the varieties of data available to us. In a non-digital twins environment, each system in a facility has its own visualization of its own silo of data. With digital twins, these silos are broken down, normalized, and organized to better match how we as humans understand the world as a collection of equipment in a physical space, with each equipment and space having properties that describe them. With the data better organized, compelling dashboards that span across multiple equipment types can be created to give the user a single view of the state of all the equipment and its environment. Creating such a dashboard is straightforward by leveraging the same twin template we use to create the digital twin instances. A visual symbol template representing the twin template that is defined, and through the data structure of the digital twin system, a dashboard is dynamically generated on the fly. A more engaging dashboard with alarms, trends, and charts driven by the augmented twin capabilities can also be easily built with the same template-driven method. So let's review the key takeaways about digital twins. Digital twins allows us to represent the physical world digitally. Digital twins enables us to break down the data silos that were created by the variety of protocols. Digital twins facilitates vendor independence by normalizing the data across vendors and treating all data from different vendors the same way. Digital twins enables cross-device, cross-system data analysis that allows us to discover hidden issues. Digital twins simplifies configuration by leveraging a templated approach. And that same templated approach also simplifies the process of creating and maintaining the visualization of digital twins. Through the combined benefits of all the above, the digital twin system simplifies change management, minimizing the effects of any change in equipment, vendor, protocol, or telemetry. And I'll take some questions.
Thank you, Z. We do have one question that came in. Do you link that you were talking about data, digital twins? Do you link that data to the building geometry, either in 2D or 3D with BIM as part of dashboard views?
It's a good question. We do. The Iconic software is capable of doing 2D and 3D, and we do have a method to ingest the BIM models that gets produced by the architecture firms, and then link them up with the data coming from the equipment or other data sources. And so you could have a compelling visualization of the space with data coming from the actual equipment itself.
Perfect. I think we're out of time at this point. Z, any last minute or any last words you'd like to share with the audience?
Yeah, so if you want to understand more about digital twins and Iconic's capabilities around it, please reach out to us. And we also have a new webcast series in support of our latest release, version 10.97. And you can register now at iconics.com/1097webcast to learn more.